ஸ்மார்ட் உங்களை அன்புடன் வரவேற்கிறது. கிராஸ்ப், எக்ஸ்ப்ளோர், வென். அனைவருக்கும் இந்த நாள் இனிய நாளாக அமைய வாழ்த்துக்கள். இன்றைக்கி ஒரு நல்ல டாப்பிக்கோடு இந்த வீடியோவை நம்ம ஸ்டார்ட் பண்ணிடலாம்.
Chapter 5 Understanding Elementary Shapes Exercise 5.5 First sum. Which of the following are models for perpendicular lines? So they have given few statements and asking us which represents the perpendicular lines. So in this, the first subdivision is the adjacent edges of a tabletop. So let's assume a tabletop. Now the adjacent edges of a tabletop. Adjacent edges meaning edges that are near to each other. Adjacent means near. So that is this edge and this edge. Now they are asking whether these two edges are perpendicular lines. Yes, because perpendicular lines form 90 degree. Here we have 90 degree. Similarly, if you take these two edges also, because these two are also adjacent edges, right? So if we consider these two edges also, we have 90 degree here. Therefore, the adjacent edges of a tabletop are perpendicular to, this is the symbol of perpendicular, but when we write in exam, we are supposed to write it as a full word, perpendicular to each other. Now B subdivision, the lines of a railway track. So let's assume the railway track like this. So this line goes in this direction and this line goes in this direction and it goes on. They are not perpendicular to each other because perpendicular lines intersect at 90 degree. Here the railway track never meet each other. So the lines which never meet each other are called parallel lines. Therefore, the lines of a railway track are parallel to each other. Hence, they don't represent the perpendicular lines. Now, subdivision C, the line segments forming the letter L. So, in this letter L, we have 90 degree here because these two lines meet each other at 90 degree. Hence, they are perpendicular. Therefore, the line segments forming the letter L are perpendicular to each other. The last subdivision, the letter V. On observing this letter, we can see only the formation of acute angle because the angle is less than 90 degree. So, these two line segments form acute angle. Hence, they are not perpendicular to each other. So, the sides of letter V are inclined, forming an acute angle. So, therefore, they are not perpendicular lines. Now, moving on to the second sum. Let PQ be the perpendicular to the line segment XY. So, there is a line segment XY and we have a line segment called PQ which is perpendicular to this line segment XY. Now, let PQ and XY intersect in the point A. They both meet at the point called A. Now the question is, what is the measure of angle PAY? They are asking us to find the measure of this angle. We already know that if two lines are perpendicular to each other, they intersect at 90 degree. So from the figure, it is clear that angle PAY equal to 90 degree, as line segment PQ is perpendicular to line segment XY. So since both the line segments are perpendicular to each other, the angle formed over there is 90 degree. Third sum, there are two set square in your box. So there are two set squares in our box. What are the measures of the angles that are formed at their corners? They are asking us to find the angles that are formed at the corners of the set squares. So the measures of angles in one set square are, so let's take the set square and see the measurement of it. 30 degree, 60 degree and 90 degree. So in a single set square, these are the three different measures, that is 30, 60, 90. Similarly, the other set square we have, right? So the measures of angles of in second set square, the other one, which we have it in the box. So those angles are 45 degree, 45 degree and 90 degree. So on looking the set square itself, we can see the angles. So in this first set square, we have 30 degree, 60 degree and 90 degree. And in the second set square, we have 45 degree, 45 degree and 90 degree. However, sum of all the angles inside a triangle is 180 degree. So that is the concept. And these are the measures of two different set square. Let me just draw a rough diagram of it. So this side we have 30, 60 and 90. So in this set square we have 45, 45 and 90. Now the question is, do they have any angle measure that is common? So they are asking what is the common angle measure, if at all there is any common angles between these two set square. They are asking us to mention it. Yes, we do have, because 90 degree is common in both these set squares. In the first set square also we have 90 degree. In the second set square also we have 90 degree. Therefore, the common angle measure in both the set square is 90 degree. The angle of measure 90 degree is common between them, because 90 degree is present in both the set square. Now let's discuss the last sum of this exercise. So in the last sum, they have given, study the diagram. The line L is perpendicular to line M. So this line L is perpendicular to this line M. Now they have asked a few questions and for which we are supposed to answer. The first subdivision is CE equal to EG? They are asking the distance of CE, whether it is equal to EG. CE is this distance 1, 2, that is 2 units. EG is from 5 to 7, that is 1, 2, again 2 units. Since both are 2 units, they are equal. Therefore, yes, since CE equal to 2 units and EG equal to 2 units, they both are same. That is CE equal to EG. Now B subdivision, does PE bisect CEG? They are asking whether this PE bisects the line segment CG. Bisects meaning is it should divide the line into two equal halves. So this PE splits the CG as CE and EG. Now let's examine CE equal to 1 to 2 units and EG, that is also 2 units. Let's draw this separately. So we have line segments like this. So now this CE is also 2 units, EG is also 2 units. So yes, it bisects because the line PE, because the line segment PE bisects the line segment CEG into two equal halves. The first half CE is also 2 units, the second half EG is also 2 units. Therefore, S CE equal to EG as both are of 2 units. Hence, PE bisects CG. See sum. Identify any two line segments for which PE is the perpendicular bisector. To find this, let's draw it. So this is PE with line segment L. Now, in order to be perpendicular bisector, it should bisect at 90 degree and also it should bisect the line, that is, it should divide it into two equal halves. So from the point E, near to E, we have point DF. This is also 1 unit. This is also 1 unit. Therefore, this PE bisects the line segment DF. Similarly, the next 2 points CG, then next 2 points BH can also be included because from the point E, the C is 2 units. That is, CE is 2 units, EG is also 2 units. Similarly, from the point E, if we travel little far, we will reach the point B, which is 3 units. The same way, right hand side, we have H. We have H, that is also 3 units. The distance between E and H is also 3 units. Therefore, BH, CG, DF are the line segments for which PE is the perpendicular bisector. They have asked us to write any two. So out of these three, we can write any two. PE bisects all the three line segments only because from the center point E, we are just calculating the distance accordingly. Now moving on to the question D, are these true? So we are supposed to say whether the given points are true. AC is greater than FG. So let's mark the distance of AC, 2 units. FG is 1 unit. So since 2 is greater than 1, yes, so the given statement is true. AC is greater than FG. Hence, it is true. Next, we have CD equal to GH. The distance of CD is 1 unit and the distance of GH is also 1 unit. Since they told like both are equal, yes, it is true. Therefore, it is true as both are of 1 unit because CD equal to GH, both equal to 1 unit. The last subdivision, BC is less than EH. The value of BC is 1 unit. The value of EH is 1, 2, 3, 3 units. Since 1 is less than 3. This is true, right? So this statement is true. Hence, yes, BC is less than EH. The value of BC is 1 unit, which is less than the value of EH, which is 3 units. So the given statement is true. Hence, It is true. With this, we have completed this exercise.
Thank you all for watching Smart. Grasp, explore, and win. Stay tuned for more videos.